idea of this webinar is to look at the different storage options and how we might be able to utilise them on farm, from thermal storage to batteries and also kinetic storage. So today we've got Ellie here from Pitt and Sherry, and she's a professional chemical engineer with 12 years of experience in consulting and delivering projects in relation to renewable energy, energy efficiency and emission reductions. Her specialist areas of expertise are solar systems and battery sizing, heat recovery system optimisation, gas and steam turbine feasibility assessments, and greenhouse gas emissions accounting. So Ellie's passionate about energy productivity, reducing costs while improving the outputs from your energy inputs. So yeah, I'll pass over to Ellie now to present to us.
Hello, everyone. Thank you, Sarah, for your introduction. As Sarah mentioned, I'm Ellie from Pitt and Sherry, and today I will talk about the energy storage option in the agribusiness. Before talking about the energy storage, I just like to briefly introduce our company and our team. Pitt and Sherry is an engineering and an environmental consultancy company that has been established in 1963. Right now, we have more than 300 staff across 7 offices in the East Coast and in the Tasmania, and we are offering different services across different industries like transportation, civil, utility, manufacturing, and energy sector. Our energy team is a combination of different engineers that enable us to understand the different aspect of energy in a different area, like a different sector, and find the best solution that actually suits our client. Our main services are the development of net zero strategy, net energy management plan, energy auditing and productivity analysis, heat recovery and heat pump system analysis, renewable energy and storage option, and last but not least, hydrogen feasibility and emerging fuel. We have a great experience in the agriculture sector that includes energy auditing of more than 250 farms in the Victoria and New South Wales. We also have a project of energy auditing several abattoirs across the country. The farm that we audited are in the different type of farm, like a dairy, cattle and sheep farming, dry cropping, horticulture, and the winery. They were in a different size, and each of them had a unique condition that we have to look at them in details and find what suits them to improve their efficiency. Some of more common solution for this farm to reduce their energy consumption first and then increase their energy efficiency are upgrading their old equipment that were in the low efficiency and their maintenance was costly, installation of VNC for their pumps and different type of motor that can increase their efficiency and reduce their energy consumption by 30%, upgrading of the light, installation of the thermal battery and the heat recovery system, and finally installation of renewable energy. Today, I will talk about the energy profile and why it is important, how it would be generated, and what you can understand from it, and then briefly talk about some energy storage option. I will show you some example of in a different location for the different farm, and finally, what would be the next step for you. The main benefits of having renewable or the energy storage on your farm is that it gives you this opportunity to control or to control your energy demand and cost. And also it can give you the social license to operate in the world that are looking for the decarbonization and expand your marketing from the local market to the national or international market. As right now there is a huge market for the customer are looking for the product that are a net zero emission, that are produced as a net zero emission, or they have a lower emission intensity. Okay, now let's talk about the energy profile. For energy profile, technically is a form of graph that we generate based on your energy data that show us very important information. It will give us the information how and when you are using the electricity, what is your main source of the energy, and how it can be aligned with the different opportunity to reduce your energy consumption, and is it technically useful for you or not. As each farm, based on the equipment that they have and how they are using their equipment, they can have a totally different form of energy profile. Here you can see that there are just 3 examples of energy profile. This one is for the dairy farm. As you can see, there is like a 3 peak for the dairy farm that are related to the milking time and also operation of the hot water generation. But for the egg producer, the energy profile can be totally different, as they need to control the temperature of the shed for the chicken during the day, especially in the midday at the summertime. And also the site might have a seasonal load, especially for the irrigation system, as you are using your irrigation system normally during the summertime from November, December to March to April. Understanding of your energy profile actually help you to know that what would be the best solution for you. This is just the example that I want to explain what would be the impact of the solar on this farm. The orange line is the typical energy consumption load in a dairy farm. As you can see, and I mentioned, there are two main peaks that are related to the milking and afternoon milking, and then we have a third peak that is related to the hot water generation. And the blue line shows the amount of generation from the solar PV. As you can see, there is a minimum correlation between the solar generation and on-site energy consumption. In order to get the maximum benefit of your solar system, it's better to have the maximum overlapping between the energy consumption and the solar generation. And the area between these 2 red lines shows that actually there is a minimum consumption on site, while we have a maximum amount of generation on the site. So it proved that actually the amount of generation at the site can't be used on the site at the same time. So it shows that the necessity of energy storage on the farm, that can be either thermal storage or the electrical storage. So in that case, when we store the amount of energy that has been generated by solar in this time, that can be from 9 a.m. to 1 p.m., the load can be discharged from the battery later at the time, or even early morning for the next day. Another factor that would be useful to understand your energy consumption is that you know what is the difference between the demand and energy, and how it would understand you to size properly your renewable option or your battery system. If you imagine that you have a tank on your site, it would be the total amount of energy that you are consuming on site. this tank would have an inlet and outlet. The outlet is the accumulation of all the power that you required on site, and it comes from all electrical load that you have on site. Can be refrigeration, heater, fan, pump, everything that you have, or all the electrical tools that you are using on your site. And what would fill this tank would be the connection that you have from the grid, or the battery that you have on site, or you are willing to install it on site. There should be a rational proportion between the inlet and outlet. It means that when you have a more load or require more load on site, you are connecting like a larger outlet to this tank. So there should be a balance between inlet and outlet. So you need to have a larger connection either from the battery or from the grid. If you are designing, if your battery has been designed initially for a certain size, so you need to have like a larger connection from the grid. And at the end of the day, the amount of the energy that you are consuming is the amount of demand times amount of the period or the time period that you are running each equipment. So for the two different farms, they can have the same amount of energy consumption while they have a different amount of demand. You can run a 2 kilowatt pump for 5 hours and consume 10 kilowatt hour energy, but you can have a refrigeration system that has a 10 kilowatt demand and run it just for 1 hour. Why it is important? Because you are actually paying for both factors. You are paying for the size of your connection and then for the size of the tank actually you are building or you are consuming the amount of energy. And when you are sizing the battery or renewable, it's important to know that what is the relation between the size of inlet and outlet. And if you have any kind of change on your side, you might need to optimize your system that has been installed before. But before investing any money for the renewable or energy storage, there are some factors that you should consider. First, review the performance of the farm and find the deficiency or that is happening on your site, as it can reduce your site energy consumption by 30% by just a simple action. This action can be insulation of the tank or cool room, or the doors of the cool room, sealing around the cool room, lighting upgrade, load shifting that is important for your irrigation system from instead of working at daytime, it might be able to work at nighttime, and it can reduce the evaporation, and also it can save you a huge amount of money if you have a two type of tariff. Installation of the VSD on the electrical motor, like your irrigation system. If they are electrical pump or even some other pump like if in the dairy, it would be super useful. And also prevent water penetration and evaporation. If you have a pond on your farm, it is really, again, helpful, as I had a farm that 50% of the water that they were saving or pumping from the water source to their pond has been penetrated or evaporated. So technically, they were just paying 50% of their money for something that didn't do anything for them. And finally, try to find the leaks through your water network, your fuel tanks, and also find some hidden load that are running all the time and you are not aware of them. As they might be little small, but when accumulate them across a year, it can save you 10 to 15% of your energy consumption. Now let's move to the energy storage option. Currently, there are quite different type of energy storage around the world. Some of them are more developed and they are more known between the people, but some of them are still under development, and they are not available in a small scale in the market. I'm not saying that it's not possible to install them, but they might not be financially feasible in the smaller scale. Some of the energy storage options are thermal storage, electrical storage, emerging fuel like hydrogen, ammonia, or biomass, and also the pump hydro. Today, we will just focus on the thermal storage and electrical storage. For the thermal storage, it is necessary that you have the heating demand on the site. Otherwise, this form of storage might not be useful for you. And you can get the maximum benefits of thermal storage when you have both heating and cooling demand, like you have a refrigeration and also you are producing the hot water on your side. It can be for the dairy or the fruit producer, as they have a cool room and they need to create the hot water for the washing and sterilization. For the electrical storage, it's the most common type of the energy storage that all of us are using it in our daily life. But if we are tending to use it in a larger scale, you should be aware that you can use it if you are mainly using electricity, like you have a cool room and it's running all the time. Please be mindful that if you have a seasonal load, battery storage might not be the best option for you, as it's running just half a year, and for the rest of the year it's not working. Thermal storage is a technology that actually can store a waste amount of the wasted heat that are available in your site. That can work as a heat source. It can be the excess amount of generation that would be generated from solar on site, and then, or it comes from your refrigeration system. As you know, the refrigeration system will take the heat from the area or the cool room and then reject it to the environment in the condenser. This rejected heat can be captured and produce the hot water or preheat the water for the hot water generation, and so directly reduce your fuel or electricity consumption, as you might have an electrical heater for the hot water, or you might have a fuel burner, LPG or diesel burner to produce the hot water. Normally, you can have a stratifier tank that can store the whole cold water and hot water in one tank, or you might need a separate tank for the cold fluid and hot fluid. There can be different arrangement, but they would do the same. The thermal storage working by itself in the closed loop, it gets the heat from the heat source and deliver it to the hot water that currently is generating on the site. But for the electrical storage, the story is a little bit different from the thermal storage. All the electrical storage are in some form of chemical energy that can be stored inside of the battery. So it's a reversible chemical reaction that happen inside of the battery. When we charge it, it goes in one way, and when we discharge it, it goes to the other way. Chemical battery or electrical battery storage are really good, and they gives you more flexibility as you can connect it to the different type of equipment. And also you can use it to control your peak demand. As I mentioned earlier, you are paying for the demand and also for the amount of energy. So by the battery, you can control some of the demand if you are paying for the demand. But when you want to when you think that you need the battery storage, there are some key criteria that you need to think about it and you need to answer them. First, what kind of technology would suit you? When you think about the energy storage, don't think that you should always invest a lot to get the chemical battery or lithium-ion battery. There are some other type of the battery that might be useful. Or if you have a thermal demand, the thermal storage might be the best solution for you. What is your energy profile of the farm? How and when you are using electricity? Is it useful for you to have the battery storage, or is it something that a supplier just trying to sell you? And what is your main purpose of having the energy storage? Are you trying to reduce your demand, or you are trying to reduce your energy consumption? As they can be programmed differently, and their technology is different. So when you are purchasing and paying for this battery, it is important to consider that and not pay for something that you are not using it. And what is your available energy sources to charge this battery? Or do you have the solar already on site? Do you have and your on-site solar, is it producing enough energy that can be stored in the battery? Do you have a refrigeration system that the waste heat can be stored as a thermal storage? Or do you have some other kind of energy that can be monitored and then be assessed, that are they good to be stored or not? And finally, what is your financial parameter? What is your expectation for the payback of this new technology? Are you expecting 3 years payback or 10 years payback? As they can be different based on your operation, based on the charging and discharging of the battery. And lastly, the optimization of the battery is really important. That should be done based on the operation of your farm and how and when, again, you are using the energy. And lastly, when you decide that the batteries are really good for you, and or you might get the consultation from someone or some expert that they say that they assess your site and they give you the advice that it actually is useful. Actually, it gives you it brings a very key benefits for your operation. It can match renewable energy supply with the business demand, as I show you for like dairy farms. It can store at the midday and be used later. It can provide quality and a stable energy supply. It means that if you have a frequent power outage on your side, by having the battery, you can stabilize the energy that you have on site. And also you can control the cost for your energy. And you might have a two type of tariff. You might pay in two type of tariff, like a peak and off-peak tariff. So your battery can be charged at the off-peak time and then be discharged at the peak time. So you can save some energy, some money in that section. Some example of the energy storage is installation of lithium-ion battery for egg farm. The implementation of lithium-ion battery has actually key benefits that they are a low barrier to entry, and they are well-known technology. A lot of company and industry already invested in that area, and you can find them in a different size, and even you can, based on your budget, you can install it gradually and increase the capacity of the system. They are high energy density, and they have a simple integration, as they can easily be added to your existing system and start operating. But these type of battery has some limitation. They can lose the charge if you are not regularly discharge them after charging. And also you can't use deep cycle them. What does it mean? It means that when you charge them to 100%, you can't discharge them to 0% and do it again and again. It would actually reduce the capacity or kind of reduce the lifespan of the battery. And also by nature, the lithium-ion battery would have a capacity degradation over their lifetime. For example, if when you buy the 100 kilowatt hour lithium-ion battery at the beginning, after 5 years or after 10 years, there would be some degradation in their capacity that comes to 90, and at the end it can come to 70 or even lower at the end of their lifetime. One alternative for lithium-ion battery is the flow battery. Flow battery are different type of chemical battery that they can save electrical energy in themselves. Flow batteries technically have a 2 tank that are filled with the special fluid that some of them are like a vanadium. And when they run through a pump, they can be charged or discharge electricity. Their main benefit is that they can be regularly deep cycle, so you can charge them to 100% and discharge them to 0%. And they have a limited degradation over the lifespan of the battery because there isn't any direct chemical reaction between them. So the amount of loss in this type of battery would be lower. They are ideal for long time discharging, and like they can be suitable for the 8 or even more discharge time. They are durable and heavy, so you don't need to be worried about them, and fluid can be recycled and recharged. But they have a main disadvantage, that is that they need a higher upfront cost when we compare them with the lithium-ion battery. And when you go to the market, you can find the different size of them, that like the lithium-ion battery that's right now available on the market. And also you need to contact some specialists to come design it for you if you are not buying it the market size, and it should be installed by an expert. But the lithium-ion, almost every electrician is qualified to work with it. And for that, this is another example of thermal storage for a dairy farm. For this dairy farm, the thermal storage has been installed in the cooling system. This thermal storage is connected to both the second stage heat exchanger that would cool down the milk, and also to the refrigeration system. The rejected heat from the refrigeration and also from the milk would be captured by this system and would be stored in the thermal tank. And this tank has a circulation loop with the heater that can generate enough hot water. And in a case that there isn't enough load, the heater would run like a normal condition to increase the temperature of the water to the required level, and for the cleaning or sterilization. The main benefit of thermal storage is that they are known technology, so you don't need to have like a specialist to run it on site. They have a relatively simple integration. They may use existing equipment. You might have some extra tank or retired tank on site. You can refurbish them and repurpose them and install them as a storage tank. Also, when we compare them with the chemical battery, they need the lower investment. But they have their own limitation. First of all, you need to have the thermal demand on site, because you can generate, for example, the electricity from your thermal storage. And another thing is that if normally they can the storage for the long time. There should be a small period of time between charging this tank and discharging, if you don't want to lose the amount of heat that actually you store. And what is for you for the next step? First of all, try to understand your energy profile. That is really, really important. In order to do that, you might need to ask some specialists to help you to get the information from your electricity meter or your fuel bills that they can make the graphs for you and then explain it to you. Ensure that you understand where is the wastage of energy on your side, and do you have any deficiency that happening, and rectify them before again investing in a renewable and for the energy storage. And finally, when you decide that this is the best option for you, if to install the energy storage, try to find out what would be the best technology for you. And lastly, engage the technology supplier to understand the cost, integration requirement, and complete the financial analysis for you for your farm. And also you can reach us if you like to get more information. Thank you for your attention, and I am here if you have any question.
Thank you for that, Ellie. I did switch off your camera partway through that, just because we did have, it was getting a bit glitchy there. So if you do have any questions for Ellie, please pop them into the chat, and we will address them in a little bit. But right now, I had the pleasure earlier this week of catching up with Fred Yonkers, who is a dairy farmer over in Gippsland at Yinna. We pre-recorded with him. He is also online today as well to answer questions, but we pre-recorded just because he does have some internet issues that he's aware of. Just a bit more about Fred. So he has installed a battery and solar system on his farm.
My son and his partner are the milkers, and they milk 310 cows at the Yinna district. And we have a 20 rapid exit dairy, 20 aside. And yeah, and we're spring calvers. The 22 kilowatt battery system and 64 panels on the roof to charge the 22 kilowatt battery system. We're restricted on how big we can go because of AusNet. They said you're only allowed to go 7.5 kilowatts per phase, which restricts us to what size we can have, because we're running 2-phase, not 3-phase. All we can export, I think it is, but it's 22 kilowatt battery system. The main process was the price of our electricity bill, and we didn't have a backup system when the power went out. So we talked to Lindy Anderson about what size system we needed to make the system work when there was no power. The system that was going to work, as well as saving money, but would work when the power went out. So we had to get a size to make that we could milk the cows. Cows, it's probably 3 hours of energy, but we can't cool the milk because that just takes too much energy. We did, when the power went out and put the system to the test, they had to come down because we couldn't get it started. And we had to tweet that the cooler pump wasn't actually connected to the silo. So the first load actually went too hot and we had to dump it. And after that, it was okay. More times when you can milk because of the way the system charges. And yeah, that's probably the main one, just so we know the batteries are going to be fully enough charged so we can save energy. And when the power went out for 7 days, we actually did milk the cows. So that was a big benefit. It used to be 24 to 2500, and now it's gone down to 1600. Just the main thing, you can get backup. You just got to make sure that the people who are doing the system have got backup, because I don't understand anything about it, because that much computerized stuff in that box they did. And so yeah, and I can always get hold of them too. The right advice that you've got the system that's big enough to handle your shed, because if it can't handle your shed, it's no good when the power goes out and you're probably still using too much outsourced electricity. Another thing we had a bit of problems with is our systems, because the people that installed it monitor the system. So we had a bit of trouble with the internet, because it had to come from the house to the system. And yeah, we had a bit of trouble with that because they could not read it, and they've had to come out twice to get someone fix out the internet side of it. Good, because it even picked up that the vacuum pump motor was actually had a bit faulty, and it was actually, when it started up, it was actually spiking heaps of power. So they told us, and we worked it out, that's when the vacuum pump started, that's where the spike was coming in the system. So that was good. So yeah, we got the motor repaired, and yeah, she's all good now. I advise people that when they get a system done, to make sure that it's got the internet connected to, so the people who supplied the system can tell you how it's all going. Yeah, I can ring up now and I can say, oh, how's the system going? And he can actually give me a printout on how it's all, the energy and everything's working out. And yeah, so that's good. We're looking at a VSD vacuum pump system, which is trying to save energy, and also see if we can get a solar system on our water pump system down at the river, because that's another big cost.
Awesome. So that was from my catch up with Fred earlier this week on Monday. So there has been one question come through so far, and this is directed at Ellie.
Yes.
And it is, which battery has the longest life cycle and how long is that? You also mentioned about cost implications on the flow batteries. How much is a unit currently, and do you envisage price decreases as the technology is widely used with time? So which battery has the longest life cycle and how long is that?
Actually, right now the batteries comes in a 10 years. As I know, it normally comes in a 10 years lifespan. But I can't advise any brand, as it's not professional. I'm sorry about it, but there are right now the great brand on the market. They are offering 10 to 12 years lifespan. So I hope that I answered the first question. What's the next?
So the second one is, you also mentioned about cost implications on the flow batteries.
Yes.
How much is a unit currently, and do you envisage that the price will decrease as the technology is widely used with time?
Yes, it would. Right now, I don't have any price in my mind, but I think that they are at least 50% more expensive than lithium-ion. But as you can see for the lithium-ion energy price, that it dropped by almost 50% from 5 years ago to until now. I expect that for the flow battery, it would drop in the same trend. So by increasing the demand in the market for the flow battery, I think that it would be cheaper at least by 50%.
Fantastic. Thanks for that, Ellie. And so we've had another question come in for Ellie and also for Fred. What are the warranty periods on the commercial scale batteries?
Is it okay if I answer?
Yep, it's fine. Yep, you go, Ellie.
the normal is again like a lifespan of the battery is for 10 years, but recently I've even seen that the guarantee for 20 years, but it can again depend how much you are investing in that area. If you are paying for like a more advanced technology that has a higher efficiency and more lifespan, you have to pay more, so you can get longer guarantee time that can go up to 20 years. But normally, if you are looking in the market, look for the at least 10 years guarantee.
Fantastic. And so with those ones that have got warranties for 20 years, even though they're a bit more expensive, would they, over the lifetime of the battery, would they end up being potentially slightly cheaper?
You mean the LCOD, the cost of the battery per amount? I think that yes, but the initial investment, I mean, the upfront cost for this battery is really high. They are normally, I think they are normally twice the price of the normal lithium-ion.
Yeah, so that capital cost will potentially outweigh the long-term gains potentially, depending on the business and what they're able to do. Fred, what are you, if you're able to speak, what is the warranty you got on your battery system?
Yeah, 10 years, but in that 10 years, they do lose the amount of capacity they can hold. So that's what you got to expect.
Yeah, and are yours lithium-ion batteries?
Good question. I'd say so.
Yeah, no, that's all good. Thank you for that, Fred. So there are some other alternative examples of energy storage, such as flywheel storage systems. Are there any others out there that you've seen applied in an agricultural setting?
Yeah, I've got to say that there is a couple of different systems. There's one that they use. It's like a big flywheel. That's another system they're trying, and it just keeps spinning.
Yeah.
So that's another one I've heard about. There's actually one system working somewhere in Australia.
Awesome, fantastic. Ellie, what have you seen around the traps in your adventures around different farms?
I haven't seen any installed flywheel in the farms that I was working with them, but definitely it can be an option, as flywheel is storing the electricity in a form of the kinetic energy and return it back. It's like a generator that you are feeding it, and it store the electricity in a form of kinetic, and then it return it back to your system. But there is, as I read about it, there is some kind of the efficiency that you should consider, that what is again your excess amount of energy resources that you want to save in the flywheel, as the efficiency of the system would drop if the rotation in the system is not in the highest speed. So you all in all, I'm saying that you should consider that how much excess energy you have on site and when it's happening.
Fantastic. Thank you for that. We have had another one come through. What about battery recycling management at the end of lifespan? Would you have any information on that, Ellie?
Not really, but for the flu battery, there are some center that they are actually selling you the flu battery. They will take back the fluid that is in the flu battery. But for the lithium-ion battery, I know that there are some company, again, they will take it back, and they might even replace it with the with some option. They might have some option for replacement of your battery with the in a cheaper price. But if you are looking for a specific center, I don't have any name on my mind right now.
Yeah, thank you for that, Ellie.
Sorry, I have two questions that came directly to me. Noel asked that I just checked house PV not generating any power at all due to overcast day in Gippsland. What do you advise in this situation? This is unfortunately part of having the PV system. If you are having solar PV on your roof and you have a cloudy day or rainy day for a several days, they are going to generate the minimum amount of electricity, as there would be less amount of radiation for direct radiation from the sun. The advice is that if you want to be off grid, or you want to be more independent from the grid, you should install the chemical battery that, or even the thermal if you are using the hot water generation on site. So you can save the generation from the days that actually have excess generation, and then use it for the some other days that are cloudy. But you should consider that how often does it happen, as if you are not using your battery frequently, it might get discharged by itself.
Yep, awesome, fantastic. Thanks for that, Ellie. I've got a question for Fred. So during the video that we recorded on Monday, you mentioned how you were able, when you had a 7-day power outage, that you were able to milk the cows through that time. So you obviously had the benefits of being able to milk. What are the other benefits to your business from being able to milk there?
Oh, we couldn't milk the cows, would have been virtually choppers, because the mastitis would have went through the roof. Probably the main thing, and just probably that the factory would pick up warm milk. I suppose that was another benefit. I suppose we're not that far from Leongatha, so it's not far for a tanker to come and pick up our hot milk.
Yeah. And so is that something you're looking to potentially do in the future? Might that be an option in the future to expand your battery storage so that you are able to cool milk when you do have those power outages?
Yeah, we've just got to mainly look at the figures and how much that'll cost. Like, would it be just cheaper to put another generator system? Yeah, be good, but yeah, it does take a lot of energy to cool that milk down. Yeah,
fantastic. And that might be another option, maybe looking at potentially thermal storage there, like Ellie was speaking about before, to potentially assist with that milk cooling, and heating up hot water.
Yeah, it probably could go. Probably the way we could do it a bit cheap is probably go to glycol cooler system, because you can cool that before. If you had a 7-day outage, you'd be in trouble. But if you only had a 1-day outage, you could cool your glycol cool enough that it would cool your milk.
Yeah.
Solar system could cool that days before the power went out.
Yeah, fantastic. There's been another question come through for you, Fred. Have you had any technical issues with the battery to date?
None with the batteries, just the internet mainly.
All right. So there's a question about, where have you seen the best utilization of solar that's minimized the need for batteries?
Yes. There are when you have a cold storage, that they normally have a constant load during the year, you have a maximum benefits of using the solar generation on site. And in that case, you can have a more than 80% self-consumption on site, and in average, it can reduce 30 to 40% of site total energy consumption.
Thank you for that, Ellie. There's a further question on that last question there, Ellie, and that was, have you got any irrigation examples?
Yes, but for the irrigation system, it is really critical. As you might, the irrigation system normally is running during the summer, that is from November, December to March, April. So you should know that what is your irrigation pumps, that if you want to connect it directly to the solar, and it's running during the day, you can get the maximum benefits of solar. For the irrigation system, for example, if you are running 5 kilowatt, or let's say 10 kilowatt pump, you need almost 20 kilowatt solar to be installed to give you 10 kilowatt a load for your pump running. And during the summertime, it is really good and the best time to overlap the operation with the solar generation.
Fantastic. Thanks for that, Ellie. Yeah, and we have seen some fantastic solar systems go on for some irrigation systems up here in Northern Victoria as well. Yeah, and they've even put it on tilting frames so that they can actually maximise the time that they can utilise that solar to irrigate during those summer months.
You're right, yes.
Yeah. Alrighty, thank you to Fred for recording with me on Monday, so we're able to get some visual in there, and also thank you for joining us on here today. It's been fantastic to be able to ask you some questions, and also thank you for Ellie for sharing the technical knowledge around batteries and thermal storage and other forms of storage with us today.